So another chemical reaction, this is one, I wrote one here. So another way of making uh, the alkene is by dehydrohalogenation of alkyl halide. It's similar to what we just saw now. Dehydrohalogenation of alkyl halide. It's easy, so don't be surprised or don't be intimidated by the name. So let's go. We have alkyl halide, CH2, and then CH2, and then X is the halide. So everything is alkyl, and then we have halide. Just like you have CH3Cl. This is chloromethane. So this is the halide there. Instead of methane, which is CH4, one of the hydrogen atom has been substituted with a halogen. So that is why we call it alkyl halide. Okay, so let's go ahead and so we dehydrate this. So dehydration in this case does not need it needs something else apart from it doesn't need alcohol. It does not need conch acid this time around. We use strong base instead in this case. For example, like potassium hydroxide is what is used in this case, and then the reaction is heated. And then how do we get our product? Just like the way we have it over there. But we're going to have three products this time around instead of two products. We are going to have of course, there are two carbon atoms here. So definitely it's going to be RCH double bond CH2. And then what do you call it? The H, the X here, that is the halogen, is gone. It will react with the K here to give us a halide, and then the OH and the other hydrogen here. Maybe I can write it. Let me draw the display formula so you get it clearer. We have C, H, H, and then the alkyl group. We have our C, H, H, and then the halide, and then plus our plus the base, the strong base, which is potassium hydroxide. And then let's look at what we are going to get. So this is how they will go. The hydrogen here will go together with this OH to give us H2O, water. When the hydrogen go, I don't want to talk about the mechanism of reaction. I'm just giving you an illustration so you understand when you want to remember for the exam. So the X, the halogen, will also go together with the potassium here to give you potassium something. KX can be potassium chloride. If X is chloride, can be potassium fluoride or potassium bromide, depends on the halogen that you use. And then plus. So what do we have left? We have the alkene left. So it's going to be R, carbon. One of the hydrogen is gone already. So it's going to be RCH, double bond, C. We have all the two hydrogen atoms here left. So this is our alkene. We have our halide, and then we have water as the product here. And this is our alkyl halide. So that is how we get alkene from alkyl halide. So let us look at ethane, H3, CH2, Cl. So you can break it down like what we have up over there, and then plus potassium hydroxide in the presence of heat. And then we are going to have our CH2, C double bond, CH2 plus potassium chloride plus H2O. So that is the reaction. And the next on our agenda, that is, we're talking about making alkene, is partial hydrogenation of alkyne, number 3, partial hydrogenation of alkyne. So how does this one go? This reaction, what are the conditions of this reaction? First, the reaction, we use catalyst. Sorry, is this one okay? I think I'll keep using this. Catalyst. And the catalyst is poisonous. And what is that catalyst? One of them is Lindlar's catalyst, or sodium in the presence of ammonia, NaNH3. So this is the catalyst. What do we call it last time? I call it Lindlar. So it is Lindlar's catalyst. So this one the catalyst will be used to add one molecule of hydrogen to an alkyne. Remember, when you add hydrogen to alkyne, you are moving from alkyne to alkene. So let's see how it goes. I'm not talking about hydrogen atom, I'm talking about hydrogen molecule. Now, hydrogen molecule is H2. So we have our R, C, triple bond this time around. Our starting material is, or our reactant is an alkyne, C, R prime, and then plus H2. So we are adding hydrogen molecule to our alkyne. So in that case, what is the condition of the reaction? We said it is Na/NH3, sodium in ammonia gas. So at the end of the day, we are going to have RCH, because one hydrogen atom will come here. So when one hydrogen comes here, the bond becomes double bond. Another hydrogen atom here, something like this. So remember, the hydrogen atom will be added across the double bond. One to the first carbon atom, the other one to the next carbon atom. So if we have like something like this, so the reaction will occur here between this carbon and this carbon. Same thing. If you have the same thing up here. So yeah, your reaction will occur across the two carbon atoms. So the one that is carrying the halide, and then the one next to it. So that's where the reaction will happen. Okay. So we have our alkene at the end of the day. So we can look at a general example in this case. So it can be HC. We can use ethene as an example, and then CH. This is ethene plus H2. So we are in the catalyst is the same. So we're going to have what? CH2 double bond CH2. CH becomes CH2. So we add hydrogen molecule across the triple bond. So what are the properties of alkene? So let's look at the properties of alkene. Number one is their physical state. What do they look like physically? Just like alkanes, or yeah, just like alkane, they are liquid. They are gases at a point, and then liquid, and then solid at a point. So up to carbon 4, C1 to C4, they are gases. And then you have liquid and then solid. What about their boiling point and their melting point? Generally, they have lower melting and boiling point to the corresponding alkane. So why? Because they are not so packed together. The atoms, the hydrogen, carbon, the chain, actually the carbon chain, they are not so packed together. Remember, this one you have many bonds to break. Apart from having many bonds to break, this one are packed together compared to when you have this. So in this case, this one has less boiling point, lesser than this. Boiling point of the alkene is lesser than of ethene, is slightly lower than that of ethane, because you, as I said, they are not so packed together. That is, the molecule of ethane are not so packed together compared to the molecule of ethane. So they follow similar trend. If when the chain length increases, the boiling point and the melting point will increase at the same time. Talk about their density because they are organic molecule.